Okay, today's lesson 9-6, maximum and minimums. Goal for today is to be able to identify whether a quadratic function has a maximum or minimum value, able to find the value of that maximum or minimum, and be able to identify the domain and range of the function. So those are the things we're going to look at. The maximum or minimum values. A graph opens upward and has a minimum value if a is greater than 0. Okay, so a would be positive, greater than 0. So a minimum value if it's greater than 0 or positive, and you can see this in this picture here. A is positive. You can see the graph is opening upward, and therefore it has a low value. If the graph is negative, A is negative, okay, it has a maximum value. The graph opens downward, which means it has a maximum value when A is negative. The range of a quadratic function is all real numbers greater than or equal to the minimum or the maximum. Okay, so all real numbers greater than or equal to the minimum, or all real numbers less than or equal to the maximum. So either you're below the highest point or above the lowest point. So let's look at the graphs here and talk about the equations and talk about what this means. So consider this equation, f of x equals negative 2x squared minus 4x plus 6. So that is our function. Determine whether it has a max or a min. So again, we're going to label A, B, C. And A equals negative 2. And negative 2 is a negative value. And if we look at our chart above, if it's negative, A is negative, it's going to open downward. Okay, so the graph opens facing down, which means there's a maximum. Okay, so the answer is it has a maximum value. State the maximum value of the function. To find the maximum value, we need to find the vertex, because the vertex gives us our max value. If you remember, how do we find the vertex? We use x equals negative b over 2a. So we're going to plug in negative, the b value is negative 4, over 2 times the a value, which is negative 2. So we get positive 4 over negative 2, negative 1. So the axis of symmetry, x equals negative 1. So then if we want to find the vertex, remember that is the x value of the vertex. So we're going to plug this into the equation. So negative 2, negative 1 squared minus 4 times negative 1 plus 6. We have negative 2 times 1 minus 4 times negative 1 plus 6. So now we multiply, we get negative 2 plus 4 plus 6, which gives me an answer of 8. So my vertex is at negative 1, 8. So the highest the graph goes, because it's a maximum value, the highest the graph will go is to positive 8. Okay, so the maximum value for this graph is positive 8. Okay, and that occurs when x is negative 1. State the domain and range of the function. So the domain of any quadratic function is going to be all real, because the graph goes left to right forever, right? These arrows are going to go outward forever, no matter whether it goes upward or downward. The arrows go outward forever. All x values are included. The range of the function, as we just talked about, is if it has a maximum, that's the highest point. Y must be less than or equal to that highest point, 8. So 8 is the highest it will go, and then it'll be any number less than that. And that's described here. If it has a maximum, it's less than or equal to. So that is the process we're going to use. We're going to do the same thing on example 2. Determine whether a function has a maximum or a minimum. So a equals positive 1/2. So that is a positive value, which means it's going to open upward and have a minimum. Okay. So then state the max or minimum value. Again, we got to start off with the axis of symmetry. So that's x equals negative b over 2a. Negative, if we have a, b, c, b is 4, so negative 4 over 2 times 1/2. Negative 4, half of 2 is 1, so we have negative 4. So now we're going to plug that into the function. So 1/2 times negative 4 squared plus 4 times negative 4 minus 9. And if we simplify, we have 1/2. Negative 4 times negative 4 is positive 16. Everything else is going to stay the same. Half of 16 is 8. 4 times negative 4 is negative 16 minus 9. If we combine those, we get negative 17. So our axis of symmetry, our vertex is at negative 4, negative 17, which the minimum value, therefore, is negative 17. That's the lowest the graph will go. So for our domain, it's going to be all real every time. Our range, if it's a minimum, that means all values greater than or equal to negative 17. That's the lowest. Anything above it will be part of the range. So now you're going to do exercise 1, which is the exact same problem. There's 3 of them for you to do. So follow those exact same steps. Okay. And then when you get to number 4, I took away the last part here, so don't worry about C. It's the same idea. What is the equation of the axis of symmetry? And then how do you find the maximum height, which would be the vertex? Okay. So you work on the rest of this packet on your own.